Good morning, everyone. That looks clear enough, correct? Good morning. My name is Oscar Garcia. Um, and today we are going to be talking about generative AI, a use case where we actually can use AI to generate code, right? And we're going to go through a scenario where this is very useful. But with AI, we are learning that it's a very powerful tool to enable us to get to be more productive as far as coding is concerned. So what you want to do here is you have this QR code here, which will take you to the resources for this presentation. It will actually share with you a page where you can actually look at the repo, the GitHub code repo for it, and some other resources as well for other areas like data engineering. So once you load that page, you'll be able to see something called AI repo or artificial intelligence repo. Keep track of that because that is what we're going to be using, and then you have time to use it at home as you wish. So let me introduce myself really quick. I'm Oscar Garcia, and my expertise is around building applications for web data, and now working on the AI integrations, which we used to do before it became a big thing, because we were 5 years ago we were already using some of these AI technologies like like text to speech and things like that, right? So, but it's something that now is blowing up, is becoming very popular. So I love to go ahead to talk about these areas and share information with you as I learn them, right? And as I do it in my experience. And I'm also an author for a data engineering process fundamentals book. And you will see the link to that in the QR code as well. But let's start, right? Really. So what is this whole thing about generative AI and large language models, right? It's really not what some people may think, that is Skynet. It's going to destroy the world and things like that. It's really far from it, right? It's really just they're just models, right? They're just machine language models that have been trained in a lot of information, right? And they're designed to understand prompts, right? And questions to generate human-like text, right? So this is really basically what it is. It's able to train from all this information on the internet, and it's able to understand some of the language. It's trained heavily on some of these languages. Welcome, everyone. To be able to give you a conversation, like if you're talking to a person, right? Where you can actually, as opposed to Google search, where it just shows you a page, it can actually interact with you and tell you things like, hey, and talk to you, right? So it's very useful when it comes to that. In this particular case, we're going to be using it for generating code, right? So, but some of the features for this really is that it can generate a lot of text, and for different focus, it can generate code generation. By the way, everyone that just came in, if you scan that QR code, that will take you to the resources. There's a GitHub repo there for AI, artificial intelligence repo, a GitHub repo. That's where the source code for all this is. And there's also other repos there for data engineering and other projects. And also a link to a book that I authored that book there, so you can read about it. So I have a session at 1 o'clock that actually talks about data engineering process. And a lot of the information that I cover is on that book. So you're welcome to show up at 1 o'clock in my session as well. Okay, thank you, and welcome everyone. So my name is Oscar. All right, so we introduced large language models, right? Just a few minutes ago before you all came in. And the point is that it's really not Skynet. It's not something to be afraid of, something that you're thinking, oh my goodness, they're going to take over my job or things like that. It's far from it, right? It's really, really far from it. But what they are, these large language models are just really machine learning models that have been designed to help us generate text. And some of that text is like code, right? Because all these models have been trained on a lot of the code repos like GitHub and so on. So they understand how to write JavaScript, C#, C++, all those things, right? So it's very simple. It's nothing that there's just really learning on its own, right? It's a training process. But the features here are that it can generate text and code for us, right? It understands natural language processing, what that really means. And we were doing that 5 years ago. I was working on projects like that 5 years ago. So it's not something that just happened, right? It's been evolving. Now it's just become available to everyone. But what that really means is that I can ask it things like, hey, help me write help me write a poem or a piece of code or whatever, and it sort of understand the intent of what I'm trying to say, like a human, right? Like I'm telling you, and you may ask me more details, or you may just give me a random answer because I didn't give you enough detail. And that's the key. That's what we're gonna get into in this presentation. It can condense, like if you feed it a book, it can condense the book and give you the highlights of the book, like trimming off all that fat, right? That is unnecessary. But those are the things that you can use it for. So you can create chatbots. If you remember, chatbots was a big thing. I don't know, but back in 17 is when it came out, and that is now moved into the whole AI concept, right? But that has existed a long time ago. Welcome, come in, everyone. So really what you see here in this graphic is that it actually takes all this input information and it uses something called foundation models, which are these models that have been trained on all this big data and data from all over the internet. And it helps you, and they're fine-tuned for specific areas, like for code generation, for answering questions, for generating images, and so on. So it's being used a lot for many things. So welcome, everyone. Take a seat, and as we go ahead. So what is the secret sauce to these large language models, right? It's really the training. The training is really what makes it very powerful, right? It's really based on machine learning, which is completely, if you haven't done that, is just a whole different concept, right? But it's really, the foundation for that is really data, lots of data, right? So it gets all these massive data sets of information, and it just trains on that. And what that means, really, if I can visualize it to some of you that may not really get the entire picture, it's just that it's learning from the data, it's processing the data and learning and learning and learning. And the way that it's learning is actually just looking at patterns, right? Patterns on the data, so we're able to identify things. And what it does is not that it's magically saying like we will do, right? So like if I say I feel cold, then you may think, oh, maybe because the AC is too low, or maybe he's in a cool weather. You start making assumptions of what I'm saying because I'm not giving you enough information. So this models really, they have a target label, it's what's called, right? And the target label is saying, look, I got all this data, but I got this target label. The target label could be the person is cold, the person is hot, the person is, and so on. So it's learning. So whenever we see this, it's cold. Whenever we see that, it's hot. Whenever we see this, and so on. It's learning, but because it has a target, right? It's not that it's actually just so smart that it's figuring things out. So that is the concept of training. And eventually, it's just really, if you want to visualize it, this is a sort of a neural network. And what that means is really it's a lot of infrastructure to be able to process that data, right? So you have an input layers where the data is coming in, right? So code repos, questions, and so on and so on and so on. And these hidden layers are the ones processing all this information, right? Transforming it. And there's a whole concept behind that. And I'm gonna cover a little bit of that, but not too much because it won't make sense. But just understand that these hidden layers is the key to neural networks, right? To be able to process it. So what you do is you do data collection, you do data pre-processing, which is cleaning, right? Just like you do data engineering, you will clean the data, you will put it through the models, and you will train the models. And then you do fine tunings on the models, right? And the fine tuning really is the key for many of us that are here that don't quite get, like, AI will do something for me, but how do I make it do something specific for my company? That's where fine tuning comes in. So fine tuning, what it enables you to do is, as you get a base model, let's say there's a ChatGPT, whatever it is model that you take, because now there's open source models all over the place. You may say, I like this model for what I need. Now you fine tune it. Fine tuning means now you grab more data that is specific to your domain and you process it against that model. And so you generate another model with a foundation in your data that has already trained the model more. So now when you ask, hey, who's Oscar, let's say, right? And it specifically knows, Oscar is this guy because I fed it my data. As opposed to if I Google Oscar and it gives me it maybe gives me the Oscar awards, right? Because that's the highest search. By the way, for you guys to catch up really quick, scan that QR code. It will take you to the GitHub repos and some other resources if you take the time to do that. So when I go through the code and all that, don't worry about like, oh, maybe he's going too fast. Maybe I can, right? So just make sure. So start the repos, please. GitHub, give us a start because that help us continue to move forward. Okay. All right. So what is this whole hidden layers? What is this architecture? What is really doing? It's using what's called a transformer architecture, and it's really not the Autobots, right? It's not that. It's just really what it does. It's a neural network that processes long sequences of text, right, by analyzing relationships. What does that mean, right? So what that means is it's looking at an entire sentence, and it's just kind of saying, identifying, oh, this and this are relevant, right? And that's what's called attention. So if you notice a reference here from 2017, Google, they came out with this attention process. It's really how they're training it. So they're training it. Look, you have a sentence, trim the fat, focus on this. These are the things that are meaningful to this. So when you talk to a human and you start saying, I want, but I don't know really, but a new car. All you get as a human is, I want a new car, and all that noise is irrelevant. It's just some venting or whatever. That's what the attention mechanism is doing for machine language, right? So that is really what the transformers architecture is doing, and is a powerful thing now. So people that are data scientists, machine learning engineers, that's what they do, right? That's what they code these new models. So fine tuning. So I talked about fine tuning a little bit. So fine tuning really is that you have a base model that's pre-trained. So all these people already trained these models, right? Companies like Microsoft, Google, IBM, Salesforce, all these companies have their pre-trained models. So a lot of them are on open source that you can grab and you can fine tune to do your own thing, right? So when you start thinking, oh, so how do I get into AI? How do I do that? Well, usually you will say, okay, I'll integrate to the API for Azure or Microsoft AI, OpenAI, or Google Gemini, and then you talk to it, right? And it will give you some good content, but it may not be specific to you, to your company, to what you need to do, right? So you fine tune that model for your purposes. So when you say Oscar, it doesn't give you the Oscar awards, but then it gives you the content that you want of that Oscar, right? Because that is what you fine tune the model to do, right? So that is the main focus of that. So this just really tells you the idea, right? So when you hear fine tuning, that's basically what they do in machine learning process. All right. One thing that is very important here is that, of course, like anything, this is expensive, right? In the sense of how do you use it? So the way they build this is by using tokens, right? And tokens, really what it is a sequence of text, right? That they sort of measure, and they sort of quantify that as a token so they can bill you, right? So they can have a limit on 10,000 tokens per minute or whatever, just like anything, because this is cloud-based, right? Cloud-based. So, but the way you should see it, though, is that you will say, so is a token a word? Is it a letter? What is it? It's really not concrete, right? It really depends on the architecture of the model. So what that means is a short word with 3 or 5 letters may be one token, but a word that has 10 letters, for example, right? Then that may be divided into 3 tokens. So it really depends on the architecture. But the point is that tokens are really, when it comes to a text that you issue to the model, it's like Legos, right? So you see a bunch of little building blocks of Legos and put all those Lego blocks, and sometimes that Lego block is maybe 3 or 4 of them attached together. You have to break them down, right? And that's really what the models will do, and will break them down and do tokens. And the whole idea behind them is that there is some concept of embedding that's beyond this conversation, but they use the vector databases and embedding to just kind of do like a quick, if you're a data guy, like an index, right, where you go straight to that record. So that's the way that they're able to optimize the model, so they're quick, right? So, but to be able to get the right information, be able to say, hey, I want to be able to get this content, right? You have to be able to give it good information, not some random information, right? So that's where prompt engineering comes in, right? So it's just really a way to say, hey, get me something based on this, and so on. So it is important to be able to be very specific and be able to give a clear prompt so your model is able to generate something that makes sense to you. If you don't give it enough information, going back again, who is Oscar? It could be anything. Oscar, the soccer player, the awards, the whatever, right? But if you give it, fine tune that prompt to give it more detail, hey, the guy that talks on AI, and you start going like that, then it will narrow that down, right? So you got to be very clear. You got to be specific to be able to do this. You have to be able to do task framing. So give it background, right? So the background will be the guy that talks about AI, the guy that did this and that. So you're giving it some background so he knows, right? And examples. In our case that we're doing generating code, give it an example. You may say, look, I want to generate code based on this type of coding, right? And you give it an example, you give it some coding standards, something like that, but you got to feed it so with some data so it gives you high quality response. Right? So in this case, you can see here is we're using the concept of a user story, right? And if you, I'm sure all of you have been know about user story, that is just a concept that says, I say something, I would like to do something so I can do something or see something, right? That's really the kind of concept for that. So how do we model that so we can use AI for our purposes? So, all right, so let's go into that. So really quick, like I said, this is the GitHub repo. You have the link. This is the AI engineering repo. So what you want to do is you want to go to the Python. We're going to use Python today, right? But you can do C#, you can do TypeScript, you know, whatever it is. The concept is how to use the APIs, how to integrate with it, and how to go about to understand how this works. If you go to this, if you guys are familiar with Jupyter Notebooks, okay, if you use Jupyter Notebooks, it's quick and easy. It's very, very good for experimenting, for doing little labs to be able to generate a snippet of codes and test it right away. But if you look at this one, right, it's called Gemini Quick Start. Can you see the code or me? Is that better? In the back? Okay. If you see this, Gemini Quick Start. So, and I'll talk about Gemini, but I just want to give you, I don't want to talk too much about without showing you something, right? So what you do is you sort of run this, right? And the way you do it in Jupyter Notebook, and you can go through the prerequisites and install and take a look at all that. I won't take too much of my time on that because we're going to run out of time, but understand that there is those dependencies, how to install this, how to set up a key in Google AI Studios or AI Azure Studios and so on, right? So you have all of this, so, right? And remember, all this is available on GitHub. Okay, so you can you have it there, so don't worry about it. How to set up virtual environments so you can your code, you know, isolate your dependencies. All this is programming stuff, right? That we all sort of know it's important to use, right? But anyway, so what you do is just really you import the libraries and you get a key, right, from Gemini. So we're gonna use Gemini now, and we're gonna use a model called Gemini Pro. So what you got to understand now here is that all of these things work with models, right? So whenever you say I'm gonna use AI, then the question will be, what model, right? And what is that model doing for you? And if it's something that is specific to what you want to do, then that's where you need to build your own model, right? And you build that model that will do what your business needs to do, and so on. But you got to tell it a model. And what's really painful here, guys, just like in the world of JavaScript, the libraries get like deprecated like every 3 months. Right now, AI is in flux. Whatever models I define and I use in today's demo, it'll be completely deprecated in 2 months from now, because they just keep evolving and fine tuning and making it better. So just keep with that, right? So there is something called Hugging Face, which has become a repo of older models where you can go get the models. But this demo, I was using some DaVinci models for Microsoft before, and they're already gone. They're not there anymore. So I have to use a different one. But anyways, just bear that in mind, keep that in mind. So, but anyway, so here, the whole idea here is that we're gonna go ahead and just create a key. We're gonna configure the key for our AI API so we can call the models and do different things, right? So I hope the internet here looks a little slow, so we won't try to run too much, right? So here what we're doing is we're saying, hey, we're a presentation about LLM models and how to use them to help us generate code and so on, right? So we're asking the model, this is live. We just went to Gemini and did an API, right? And this is taking us to a point. This is taking us to a point of how to write prompts. Okay, so, but this is just a normal interaction. And we're saying, hey, explain to us how we can use it. And it's telling us, right? Oh, GPT-3, ChatGPT, Bloom, all these models you can use, they can help you for code completion, code generation, code debugging, refactoring, right? So you start learning what it can do and how it can help you, right? But then you start going like, hey, let's write some code. Let's do this and write some quick code to see how this can help us. And we're saying, hey, write a code to select the biggest number from a list. And we run this, right? And it will say, okay, this is what I got. And that's the result of the code, right? After running it, this is what it will generate. So what's wrong with that? Do you guys see anything wrong with that? Or anything, does it do what you need it to do, right? At first glance, it does. A simple code, it's okay. No data types, nothing. But then is it because of the model? Is that model not good enough to give you that? Or is it because when I created a prompt, I only said, create me some random code to do something, right? Not good enough. That's where you start. You need to refine your prompts. So now let's look at an improved prompt, right? So now we're going to say specifically, write using Python, right? With these specifications, use this function name, right? Use this inputs integer, right? And start giving it more information as you would think when you're writing code, right? Because you go and start, okay, I'm going to create a function, I'm going to return this, I'm going to take these parameters, and so on, and so on, right? So when you run this prompt, okay, thank you. When you run this, right, you create all these things here, right? It starts giving you now a little bit more documentation. It starts giving you data types. It starts giving you all this information now that is more relevant. So it looks more elegant, more complex. It's saying, hey, use the built-in function max as opposed to some loop because it's optimized, right? That's really how that works. So it's simple. So this is just starts giving us that interaction of how to do this, right? So when we look at OpenAI, Azure now, this is Microsoft now, right? And we're using OpenAI on an Azure deployment. What that means really, OpenAI is an independent company, right? Microsoft got it, and now Microsoft is doing deployments on Azure Cloud for OpenAI services, right? Then you can start going and start saying, hey, we're gonna use user stories to fine tune this information, right? And then we can say something like, hey, this is just to us to remind us how we write user stories, right? As a user role, I want to, so that I can, or the purpose of it, right? So remember that, keep that in mind. That's the whole purpose of the user story. So we're asking it, hey, give us what that means. And it's just giving us some random stuff, right? But now let's say we want to create something more specific, right? And more specific is we give it more context. As a data engineers, I want SQL technologies. I want to do this. I want to name the table like this with this column names. And I want you to build a script for me, right? So now we're being very detailed in telling it, right? So the key here that I'm trying to drive at you is you got to be very detailed at your prompts, right? That's the whole key, right? So, and then that translates into something that we do in real life. And I'll show you that. So it starts going and it starts giving you the code, right? So think about this, right? This is really what we're doing, experimenting, modeling, getting an idea, a proof of concept. Does that work? And then you have to take it to the next level. How do we automate this, right? But that's the idea here. So you say create a React.js component, and you see the same prompt, and then you see all the results, right? You see the code. If you know React, you'll understand that component, and so on, right? If a Kafka, C# Kafka consumer, and so on. So the idea is that you are here, you're playing with it, getting your feet wet, and understanding how this works, right? So the idea then is that now that we know this, and we know that prompt engineering is really good at it, right? So let's look at a real use case, right? So we talked about user stories, but what is really a practical case for us, right? So if you guys show at your jobs, they make you write user stories, or some BA or whoever's writing user stories, right? So then as a developer, you can actually write user stories to help you automate some of the stats, right? So you can go to GitHub and write a user stories as you start giving it, you know what, I would like to do this type of stuff, and give it enough detail. And then if you integrate with that and you actually go and write something that will get the user story from GitHub and then use a AI model to generate that code, then you can write a pipeline to do that, right? And it's code generation on the fly, automated, right? As opposed to back in the days, some time ago, there was a big effort in development where you created code using templates. And that was a pain because templates were so rigid. They're really not dynamic. And you always needed to change it. But it was good at saying, if you have a table, then use the SQL script and so on. But they're very rigid. With AI, that is not the case. It can generate all this code because it has all this information to do that, right? So remember, though, the code that it will generate may not be perfect, so you have to always review it. That's important. And how does this impact us, right? When it comes to development, it helps us do code completion, code synthesis, right? Refactoring, documentation, code translation. So it really makes us very effective because I know a lot of us are very lazy when it comes to documenting our code, right? But it's very, very important to be able to say, when you write something and say, explain what that's doing, or document this, right? And then you can just tell the AI, especially when you have Copilot, if you have GitHub Copilot, you can say, document this function, and boom, it will read it and document it for you. So think about it. Instead of you spending 5 minutes writing the documentation, it will do it for you automatically, right? So, and of course, you have to be concerned also that as it is a new technology, is evolving, and there's going to be a lot of hacks, right? They're gonna attack it. They're gonna inject that code to do some illegal stuff and so on. So we have to be aware of that, right? So like I said, Copilot, right? So familiar with Copilot, GitHub Copilot, right? So it's worth it. Do the trial if you haven't. If you're using Visual Studio Code, for example, you can actually, once you have Copilot loaded into your environment, you can actually put comments and say, like brainstorming, right? I want to write a function that does this, that. It will pick up that comment and it will build you a code for that, right? So imagine the productivity, right? It's tremendous. So, and then you get to change it, and then it fine tunes itself, because what it will do, it will look at your coding standards in your project, and it will try to follow the same standards, right? Which is very important. So you write less code, but you actually code more because you're really becoming more efficient at. You have a peer programmer that's assisting you on the day-to-day, on the basic stuff, right? Especially, and also the hard stuff. But imagine if you had to write an algorithm you haven't done in a while, right? And you don't remember because whatever, it will generate it for you because it has all the learning from other projects. So it's definitely going to teach you a lot of stuff too. It's going to really make you learn things you didn't know, because you will just generate some code that you'll be like, is that good? And it will generate some code that you will say, no, that's really bad. That doesn't perform. And you tell it, this is bad performing. You know, I want to be able to have some kind of a, I don't want to do loops, for example, right? I want to do something. I want to use a hash table, whatever it is that you want to optimize the code to do. Then you have to tell it, and you code it, or it will code it for you. But if you give it the right information. So we talked about Gemini AI. So just the big players, right? Google, Gemini AI. It's a great library for studio for AI. Same as Microsoft, OpenAI. You know, they have all these models. You can integrate with these models and so on. So you can go ahead, sign up for Gemini and Microsoft OpenAI, and get some keys and integrate with it, right? Azure AI Studio, the same way. And if you notice here, one thing that's interesting about Azure AI Studio is that it will allow you to look at a catalog of models and use that model for your API integration. So the way it really works is you see a bunch of models here. You pick one model and you deploy it, and that your API, and then that generates an API that you use, which is what we called, and I'll show you really quick. But then what it does is actually creating a hub for more models. If you see, it's hosting Databricks, Snowflake, and so on. So you have a lot of models there. So they're becoming hubs, right? And if you want actually free models, because OpenAI costs you money, Look at Hugging Face. Hugging Face is a hub that's free, and you can actually look at the models there and use them without having to pay anything. Because that's one thing with OpenAI. OpenAI is very expensive. Gemini is cheaper when it comes to, because they're trying to push it to the community, right? For us to use it, so it becomes cheaper. So my buddy there is telling me to go take a look at more code. So let's take a look at that. All right. So what we want to be able to do now is let's look at the project here, right? So this is the AI engineering project where we have all the source code, right? So let's take a look at this one here. And if you notice here, right, we have a user stories here that says user story, stack as user story, right? And if you look at how we code it, right, as a database developer, I want to do all these different things and look at it, right? Look if we actually were able to write specifications this way, our code quality will be tremendous. One thing that I see as a plus benefit of this, and believe me, I've seen it in my career, developers tend to ignore documentation and brainstorm, right? We tend to I just start coding. But what we end up coming out with is a lot of times is low quality because we're not thinking through it. We're not brainstorming enough. We're not writing specifications, right? Because that's the nature of it. But as you learn that this is very, very important, when you write this, you visualize what you're gonna generate. And it makes you stronger, a much better developer. And on top of that, the other is that if you have governance in your company, this is great for that, right? For governance, it's documenting everything. But then if you were to do this, whenever you're ready to code without AI, just writing this, when the moment you jump on your Visual Studio, your code quality will be high just because of doing that exercise. Because you are actually thinking through it and understanding. A lot of times as you go through, you will notice, oh, you know what, that's not going to work. Why am I doing that? And then you go back and you change it. When we code, we focus on the coding, right? And when we run it and we see it blow up and all that, then we're thinking, why is it blowing up, right? And we kind of like do it after the fact. We're reactive, right? So this is a very good exercise. But the point here is that this is a user story and we're giving it specifications, requirements, and desired outcome. It's really detailed so our model can generate something great. Okay, and we tag it as user story for a purpose. So let's take a look at that. Why are we doing? So when we come here, right, and you go to the Python folder and open this file, right, what you will see here is, it's a Python script. You can run it from the CLI, and it will just give you, hey, give me parameters, and you're going to tell it what the repo is, what the label is, in this case, user story, and what the provider is. So the provider will be, in this case, we'll use Gemini, or we can use OpenAI, right? So, and the way it will do it is behind the scenes, it will just use a factory to be able to determine what provider to use. But the idea is that it will go and it will run and it will say, okay, process the issue by label. So the whole code really is here. And what it will do is we'll go hit GitHub service and it will say, give me all the user stories or the issues that have this tag, right? And they're still open. And it will just run through them. And as it reads the content, it will create a request to your AI and say, hey, use this content as my prompt and give me a response, right? So what you will see is that it's going to get the provider, right? And then it's going to say, okay, service, create, right? So let's take a look at that. What does that do? So if you go to the services folder, right? And you will see there that you have Gemini, you have GitHub, you have OpenAI. So you have all the services here. And of course, it's open-ended. You can add other providers, right? And so on as you maintain that factory class. So what you will see is that as you load your factory, it will determine what the provider is, and it will find it, instantiate that, return that to the code. So, but let's look at that. That is coding, right? So let's look at AI is what we're specifically looking at here. So how does this work, right? So the Gemini service really is very simple, right? Very simple signature. We're just really using a base model for it. And we're saying we get a prompt, we generate the content, we send it back. That's all. That's it. That's simple as that, right? So very simple. It's just really that configuration to be able to what model to use and so on, right? So that's the Gemini service. And if you look at the Microsoft service, it's basically the same. But they vary a little bit. There is no consistency yet in everything that they do. So just bear that in mind. So anyway, so it does that. And what it does now, it says, hey, I'm going to go ahead and get this code back and send it back to GitHub. So what it does, it says, you gave me a user prompt, a user story as a prompt, and I'm going to send you back that code. So it will add it as a comment on your GitHub. The purpose of that is that now you can automate that, right? You can automate the whole thing if you want it. But usually the process will be the task will go to a reviewer that will review the code and then say, yeah, I approve this code, right? It has to be reviewed because we can't rely really that we can't guarantee that that's going to work 100%, whether the quality is 100% there for you, right? So, so then what it will do really quick is, and to show you the example here, let's say, go back to the prompt, right? So you will see here that when we built our models, I'll show you really quick. We say here, use GPT-4, for example, as a model. On this case, right, for the Microsoft one. For the Gemini, we say use, I can't remember that model name right now. So Gemini Pro, right? And how are those things defined, right? How do I figure that out, right? So what happens is I'll take you just to the Microsoft deployment. So I create a deployment really quick. So what I do is I say, hey, look, create a deployment and use a base model. And these are the base models that you have here, right? And you can see what they do, what are they meant to do, and so on. So what happens now is I can say, okay, I think I like this model, even though it's like a base library, so to speak. It's not going to do exactly what you want, but maybe it's good enough for what your requirements are. But then you actually say yes, and you create that model. So now this is called deployment, but you see the model name is GPT-4, right? And that is the model we use on our code, right? So that's what we use here, right? And Gemini the same way. So that's what we use here. So model is key. That's the key to be able to do this. But going back to the code, then what we're gonna do here is we're gonna give it a label and a provider, and the model is built into the services, right? We won't give it an option because you could do it if that's your requirement, but the whole thing is to be able to run this like that. So, and the idea is as you run this is that you can run this from the command line like this, right? And what it will do, it will try to, so I'm gonna uncomment this. And what that will do is it will say, put the comment back to GitHub, right? So, but remember all these things, you got to be in your working directory. So let's do, right? All right, so that's the working directory, right? And we can just go ahead and append this and just let it go, right? And they'll say, okay, so see what it's telling me now. Yeah. Module not found, right? So I won't be able to run it from here because now that code that I have has some problems. Let me see exactly. Okay, so I have here all of my Google Gen and have all the libraries in there. Okay, so let me see. Okay. So I have the services in there. So, okay, so it won't run it. So we'll run it from here. So essentially what it will do really is just like we did here. Generate a prompt like this, right? So it will just grab that content, get it from GitHub, run it, and send it back to the GitHub repo as a comment. So what it will do as it processes that information, right, is that it will add this comment like this, right? So it will read the user prompt that we send it. We call the API. It will respond a model, and you can see the provider's Gemini, right? And it actually gives you that response like this. And if you notice, then as I play with it more and I created Gemini, I also created for other ones, For example, the data frame here, Python data frame, you see responses like that, right? So you see the code actually giving you the response based on, as you fine tune the prompt, you can actually get more in the code generated back and so on. So you can see how this really what it does as you start building this out, right? This is a React component. It will just feed this back and even document it for you, because I told it, right? And please document this, and please do this for me, and please, I gave it enough information, and it just gave me this component. And this component, as I review it, is pluggable. I can just grab that and plug it into my project because it's really meeting all the requirements that I told it to do, right? So that is really how easy it is to that it works. So, but all you have to do is the same as Gemini, as Microsoft. You got to generate a key from Gemini, right? You got to create a project, you create a key, and then you use that key. And the way you use it is when we generate our prompts here and we read this key, by the way, we use environment variables to load the keys, right? Like that. And this is just a configuration, right? So what you do is you really want to read the documentation that tells you install these dependencies, register in this service, create this key, and put it into your bash RC file. So it loads up as an environment variable. If I were to type this from the console, I would see the key for my project, right? So just follow those standards like that and read this, and you will see how you can actually go ahead and integrate with the APIs for either Gemini or for Azure or whatever other model you may have. Okay. So let's see. Okay. So in reality, so the large language models, as we understand it, right? So all these companies are building these models that we can use, GPT, Gemini Pro, and so on and so on. You have to find out what is the best model that works for your purposes, right? And usually as a company, that model won't work out of the box. So you have to use it and you have to fine tune it. So you have to grab your data and process your data and fine tune the model to your data. And once you do that, then you do a deployment. And the deployment, really what that is you can use AI Studio from Microsoft or whatever. And all they do is they deploy a model file, like a DLL, if you remember back in those days. And this gets wrapped around an API, right? And if you're interested in seeing that process, look at my machine language repo, and it goes through how to build models and how to deploy them and how to wrap them on Azure functions, for example. I go through that exercise and I do that and I deploy, and then I can call it to do that. So because what I have done is, what I have done here is that if you look at it, and this is really now, this is from the really building models as opposed to using a model, right? This machine learning. And what you want to really do here, if you really want to get your hands really in deep into this, you look at projects, and you can look at this project, drug interaction and heart disease risk. My background, I work for medical systems, right? I built software technology for that. And this is just a machine language model that really tells you how to build this a machine language model based on your data and based on historical data, how to detect heart disease, cancer, and so on, right? So this goes through the entire exercise of doing that. So if you're really interested in doing this, you will see the process, the training process, and how to build those models without any problem. So just take time to do that if you're interested. And this is very, very so you have in this project, you have a lot of stuff here. So in the other one, AI is really mostly, AI engineering is mostly how to use large language models in the sense of API. This one is how to build models using machine language, which is a total, complete different ball game. So just kind of be mindful of that. Okay. All right. So some of the common tasks when we're using large language models is really code generation, natural language processing, right? Answering questions. So we need to be able to understand the architecture, like transformer architecture, how that works. And attention mechanism, right? So remember, ignores everything else and just calls out the meaningful words in a sentence. That's how these models work. prompt engineering, that is key. We need to be able to understand how this prompting works, okay? And of course, how to leverage code generation for user stories. Okay, so at this point, this is the repo, AI engineering. You can just scan it. You have done it before. You can visit that and review the code and ask any questions right now. So right now, I think we're just 10 minutes away. If you have any questions, please shoot. Anything you guys want to ask, it's an open forum right now. Anybody? Okay. Yeah. So, but anyway, so as you have free time, guys, just go ahead and look at this code. I won't be spending time trying to dig in. I don't want to bore you with that process right now. But eventually then, as you run this, you'll be able to get the experience. But I want you to understand the process is not the coding, it's actually the understanding how they work, how the models work, how you can use them, and how to leverage them for your purposes, right? Let's see. Okay. Okay, so I found the problem, guys. So my bad. So one thing you will notice here is that what you will notice, and I always forget this, guys, because I have so many environments. This is key, right? So how to run it, right? So how to run it, really, I totally forgot that I have a virtual environment loaded here. And the libraries for this AI is in that virtual environment. If you guys don't understand, that's like writing a container, right? To maintain the same library. So what you want to do is just launch the shell, right? And what the shell will do, it will load a virtual environment now where those libraries are defined. And at that point now, you can just go ahead and run this code. Right? And what that's doing now is actually going to GitHub and saying, hey, give me that issue. And he found that issue. He found the SQL issue, right? Right. It went and he said, hey, look, let me get the user stories that are tagged as user stories, the task. Let me have the prompt. Let me send that to the AI model, and it generated this code on the fly, right? So you can see that we are putting here the results. And once you look at the code, what the next step of that is to say, hey, let me post the comment back to GitHub. And you see at the bottom, it says posting coming back to issue number 4. And if we take a look at that, right? So now we're going back to the AI engineering. And we take a look at issue that is tagged as user story. And you can see one of the comments at the bottom, right? 1 minute ago, we actually added a comment and we put that result right there. So now you automated the process. The user story was read, was processed by the model. The model gave us the SQL that we needed for that, and it runs properly. So now, if you wanted to do another example, then you can just say, and I'm just doing it one at a time. Remember, there's a token restriction here. Remember the token restriction? So I'm just kind of saying, look, I don't want to do any more here. Let me just go ahead and remove this user story here, right? And I'm gonna create maybe the data frame. Let's do the data frame. It's a smaller prompt. So right. And now what you do is you see that it will be tagged as a user story, right? You see the user story, and now you can go back and run the same thing. And now what it will do is it will go ahead and read that user story, right? And it will say, okay, transform the data frame by merging, right? It reads what the issue is, and it's going to go ahead, turn around, send it to AI, and then that is the output of that, right? And we send it back to GitHub, and then we take a look at this, and we look at the last comment. And as you can see, I ran this a few times already, right? And this is the last comment that we have, right? So it's added, it's just recently added, and this is the code that it generates. As you can see, the quality of the code is pretty decent because I took the time to document it really well. If I don't do that, then the quality will be just very plain vanilla, like you saw on the previous exercise that we did. But with that, any questions? Anything that you may think of that I left open that is not clear to you guys? Yes, go ahead.
Thank you for the section. Very good. Question is how security when you run this stuff. And I mean, the next step from this is obviously you wouldn't write a story based on nothing, right? You would usually have some kind of data set, right, and start from there. So, but where does it wind up? Like, how does it be when it runs in the cloud? Where is it being stored or?
And what the users?
Well, it can be. Well, let's say we start generating code, right?
Okay.
I'll give you one example. Let's say in Python, right? You'll go, let's say, get a sample data set.
Correct.
Let's say, build me a table generation using SQL Alchemy. So you would want to give it some kind of data and start from there. So where would that wind up being? Like, how secure the whole thing is?
Okay, so let me try to explain it. So let me see if I can get to your point. So what happens is the user story itself, as you write it, is on GitHub, right? That's cloud. So whatever you put there is going to be on that cloud. So if it is a public repo, then it's going to get exposed. If it's a private one, it's going to be private. So you just got to be mindful of what the data is, right? So if you give it sample data, you have no problem, right? Now, when it goes to the AI itself, AI doesn't store anything, right? There is only a caching mechanism to be able to understand conversations. And it's kind of like, if you want to call it, it's kind of a session base where it knows that it has a conversation. Like if you open the same window for that chat, it will know history before, even though you took 3 days later, right? Because it has a reference point to say, I had a previous conversation, so I know context. And they do that on the cloud, right? So that is cloud infrastructure. So I guess I'm trying to answer your question is whatever you interact with these models, and if it's hosted on Gemini or it's hosted in Microsoft, their caching mechanism and so on, their audits, because they know what you're sending them, they're going to have it. Just, so you probably don't want to do sensitive data at that point, right? But when it comes to this type of exercise, is code. Whatever you're trying to write, it's already written 100 times on GitHub, right? So what the security concern should be really is on the malicious code, right? It should be that your models can get hacked, right? And when you're saying, hey, do this and do that because I have a banking system and so on, then that model, if it gets hacked, it can generate some crazy code to do something, right? Something malicious. That's where the security is. So, and you'll see it as we move forward. You'll see how this code generated by AI, you start seeing attacks, right? You will see, oh, they hacked that model and they did that. And you will see that because it's just a normal trend of technology. As new technology comes in, new hacks appear, right? New malicious attacks and exploits show up. So that is really the biggest concern, which is something that I address here on one of the slides is just be careful. Security concerns, right? That is really, and the other biggest concern with AI really that all these companies are trying to guard against is the be inclusive, don't be insulting, right? Don't be vulgar, because they can hack those models to do all kinds of crazy stuff, right? To say, hey, write a poem, and that poem can be completely garbage, insulting garbage, and so on, right? Those are the things. Because think about the models, right? It's really, it's you having a conversation with someone, but how do you censor that person that's very, very vulgar, right? It's very insulting and demeaning to people. That's really where because you treat it that way, that's really where the problem is with those models. right? It's really the content that, imagine some of these bots that go to Twitter and whatever, all of a sudden they are posting, hey, this stupid person did this, and insulting material, right? That is where it can get really ugly with AI. Okay, those are really the securities and the concerns with AI. Yes. So think about the scenario, right? So you will use. I hope I'm getting your question right. If you're using Copilot, it's because you need a peer programmer, for example. You need someone that's actually there with you, and you're not even dealing with models or anything like that. That's completely obscure to you, abstract, right? You don't understand models or anything like that, because Copilot is smart enough to read it's trained highly on code. So he knows that you're saying write a stored procedure, give me a class, define a class, and so on. So he will generate it. You use Gemini for this kind of purpose. Now, if Copilot is not in your environment, you need to call an API. You use Gemini, you use Azure OpenAI, and you automate some of this process. Because the next step here, if you build a pipeline, is to actually grab that text, go through an approval process, and then create a file or whatever it is that you're trying to do. But at the end of the day, the goal is, if you just get to this point where you actually get a response, right, on your repo like that, imagine the velocity of your projects, right? Imagine the velocity of your projects, right? You'll be there much faster. You won't get stuck. Remember how we gotten stuck maybe on some algorithm we're trying to do, right? This would break through those walls. You won't be like hammering yourself going to Google, how do I do this, and get like 10, 20 different results that you're like, which one is the one that's right here? I'm confused. So it will just accelerate this, right? So just be mindful of that. Does that answer your question? Okay, so remember, this is more for automation. OpenAI is more for building smart apps. If you're a web programmer, mobile programmer, and you're building applications, you integrate these APIs to make your applications, for example, a chatbot, right? It's a typical example that's been around for 8 years or more, but you can actually say to it, hey, help me book a ticket, a flight, right? Book a flight. And it knows the process because it's been training to do that. So it's easy. So that is where applications become really smart. That's where you can actually go. For example, I written applications where you talk to the computer, right? So you're saying, hey, like a Copilot, and you're saying, hey, help me do this. And it will use natural language processing to understand it, to process it, generate text. The way it works, generates that text, sends that text to a model. The model understands it and it generates content back. We process that text back and we create an audio file, and then we reply it with voice. And that's been around. We were doing this more than 7 years ago, right? But it was more expensive. It was longer to build. Now it's so much easier. Now with these models, you can just quickly do this just by using a little bit of code, and you will be there. So those are the advantages. That's the advantage of AI this day, that it has the power, and the libraries and the studios in all these different companies will accelerate your programming. Okay. Thank you, guys. We hit the number 9:30. Thanks for coming. Sorry for the hiccups. Thank you so much. Oh, and don't forget, so 1 o'clock data engineering process. If you're really a data guy, that goes into how to build data pipelines in the cloud, but really through code, right? Not just I'm gonna use some tool like Data Factory and just click and drag and click. And no, this is really using code and how to build a data pipeline from deployment all the way to production using Looker Studio. Looker Studio is like a Power BI platform. So you will see really quick, guys, you will see, and like I said, that actually touches into that book that I talked to you guys about. But if you really interested, I give a different perspective. I go more into the process of building a data pipeline with hands-on coding, right? So we really go into how do we build this from a problem statement, we need to do this, into actually let's do data, let's do a discovery, let's do design and planning, let's do architecture, let's do implementation, and so on and so on and so on. So if you're really interested, if you like building data warehouses, this is really the place to be. All right. So thank you guys.